शुक्लांबरधरं विष्णुं शशिवर्णं चतुर्भुजं प्रसन्नवदनं ध्यायेत् सर्वविघ्नोपशान्तयेत् वक्रतुण्डमहाकाय सूर्यकोटिसमप्रभा निर्विघ्नं कुरु मे देव सर्वकार्येषु सर्वदा बुद्धिर्बलं यशोधैर्यं निर्भयत्वम् अरोगताम् अजाड्यं वाक्पटुत्वं च हनुमत्स्मरणात् भवेत्। सरस्वती नमस्तुभ्यं वरदे कामरूपिणी विद्यारम्भं करिष्यामि सिद्धिर्भवतु मे सदा। पूज्याय राघवेन्द्राय सत्यधर्मरथाय च भजतां कल्पवृक्षाय नमतां कामधेनवे दुर्वादिद्वान्तरवये वैष्णवेन्दवे श्रीराघवेन्द्रगुरुवे नमोऽत्यन्तदयालवे। आपादमौलिपर्यन्तं गुरूणामाकृतिं स्मरेत् तेन विघ्नाः प्रणश्यन्ति सिद्ध्यन्ति च मनोरथाः। श्रीगुरुभ्यो नमः। So this is the third topic that I am introducing in the OOPS, which is called inheritance. So what is inheritance? Inheritance allows to create classes which are derived from other classes. So it will automatically includes some of the properties of its parent. So what does it mean? So here we have a class called person, and this person has name and address. Okay, and then so now we want to create a class called student. So a student also has name and address, and also has additional things like which college he studies in and which class he studies in. Similarly, we want to create another class called employee, who does not have college and class, but he has something else. He has name and address too, which is common to both student and employee, but he has something else called company and what is his designation in the company and so on. So why do we need this kind of an arrangement where we have a person and then student and employee derives is an inherited or children class of person? Because as I said, in C++ we want to focus more on design where the code is more reusable, less buggy, and it is reusable and things like that. So it is, in this case, when we say object oriented, we try to create objects which are meaningful and which are contextual also. So here what happens is that the person has some class, some members, say name and person, and maybe has some methods called getName, getAddress. So the students and employees, since it derives from the person, it automatically gets the same functions and same attributes. So why is this required? Now I don't have to write the same thing twice in C student and C employee. Not having to write twice also means that, say in future in the project they say, okay, now every person needs to have a Aadhaar ID compulsory. So then if I had many classes like student, employee, doctor, engineer, this and so many other things, so now I have to go and make changes in every other class that, okay, this person needs Aadhaar ID, this person needs Aadhaar ID, and then this is the way to update Aadhaar ID. So all these things will get duplicated. So by just having one class called C person, if I just go Aadhaar ID here, now automatically student and employee also will get Aadhaar ID because they derive from the same class. So are we all clear like why inheritance is required and what is the parent class and what is the children class? Okay, good. So this is one of the, let's go into coding right away. Okay, so for example here we create a class called C person. Okay, so here we create string name comma address, right? and we write two functions which return string, get name okay, and get address. Okay, so this is a person class, which is a simple thing, which will get name and get address. So now I have another class called student. So to inherit from the person, the syntax is we write a colon and then we say we publicly inherit C person. So we specify the storage specifier. Again, storage specifier could be public or private and so on. So I'll come to what the storage specifier, the access specifier here signify. So this is how we inherit student colon person. Okay, and then here I have my own private variable for student, which is college and college and grade, which grade, or a school or grade, whichever. And then similarly I have some public accessors called get school and get address. Not address, get grade. Okay, similarly I have another class called employee. Instead for employee we have company name and designation. So similarly we have get company, get designation. Okay, so here we can create a class, either a C person or we can create a student or employee. So I told you that since you derive from the once you derive from the base class, so this C person is also called as base class and C student is also called as derived class. So since the derived class derives from the base class, we automatically see the functions which are not only in that class. Like for example C student, we not only see get school and get grade, we will also see get name and get address. So if I say p dot, I can only get address and get name. If I say s dot, I can see get address, get name, get grade, get school. Similarly for employee, I get address, get company, get designation, get name. So did you get this part? Okay, so now if I'm not using person, right? If not using person, let me remove employee for a while. So how do I set name of the student? So say I create a constructor here called C student, right? And I take string name, string address. Okay, so I should be able to set the name, this name, but I'm not able to see name here. So how I'm going to see set the name? That is because the class will not inherit the private members. In this case, name and address are private members. So the class won't be able to, the inherited class won't be able to see the private members. So but I cannot make it public, because if I make it public, what will happen is even the user using this one, he will also be able to see it. Say if I make this public, the problem with making this public, I can set name equal to, if I can set here this name equal to name, this address equal to address. I can do this, but the problem is this is unintentional, because if somebody says s dot, even we are exposing the private members which we don't intend to expose. So what C++ does is it has come up with a new another accessor called protected. So when I say protected, it is available to the derived classes as intended, but it is not available to the client programmer who is using the library. So again, this achieves abstraction by giving the derived classes access to the protected members of the base class, but whoever is using other classes won't have access to the protected members which do not derive from the class. Is it clear? So let us take one live example. So before we go there, okay, yeah, let's go to the, let's take a nice example which we can demonstrate not only object oriented programming but also inheritance and all those things, all those concepts. So say I create a namespace. I have to create a project called home automation where I have to control different devices in the house. Right? This is like a, say, a real world program or a very practical program. I create a namespace called home automation. Okay, in the home automation I create a class called device. So in this case we'll give two methods called on and off. So in the on, we can probably, if there is some library function to kind of send some signals to a particular port. So we need to know in this, a device will have an electrical port, right? And every device will have its own electrical ports. So we'll define a private variable called port, and in the on function, say we'll call some function which will send signal, on signal to the port. So how do we set the port? So we create a constructor called device, which takes the port number, and then we set port is equal to P. Similarly in off, we will send the off signal to port. So now we have created a device which can on or off a device. So in case if I want to create a port, if you know the port number of say the fan, I'll say device fan equal to device fan port is 10, so I can say fan dot on, and I can say fan dot off, right? Yeah. So but like fan has many other functions, like TV has many other functions, different functions. Like TV, you can increase volume, decrease volume. Fan, you can increase the speed, decrease the speed. And computer, say you can open the DVD disk drive, close disk drive. So we'll take, let's see how to kind of, but they all have common functionality. They're all devices, so they will have ability to turn off and turn on. So what we can do here, we'll create another class called TV, which will derive from device, and then so automatically when I derive from device, it will have on off ability. So I need a constructor because the TV has a different port, so I need to specify the port. So I'll create a class, I'll create a constructor which will take the port, okay, and then here the port I'll make it protected. So here I can say port equal to P, right? So what is this? It says no default constructor exists for class device. So what it does is, so what does this error mean? So since we derived the TV from a device, so I know how to initialize TV, but here I am not initializing the device because device object also needs to be created, right? So I need to initialize device also because there is only one constructor we have defined which takes the port P. So how do we call the constructor of device within TV? So that there is a way to do it, just like how we use colon here to derive. So we can use colon here and we can call the constructor of device. And device doesn't have a default constructor, it takes an input which is port. So we can pass in whatever input comes to the TV to the device, and we need not set it here because we know there is only one port which is part of the device. So whether you set it here or here, it's both same. We don't need this. So this way, from the inherited class constructor, you can call the base class constructor by passing the values you need there. So if I create a TV, let's come to that part, but before that I want to say void increase volume. So I will have a function called increase volume, and by how much, I'll take input by how much. So here I will also store what is the current volume. So here I will do volume plus equal to step. So if I create a object called TV, so it takes a input which is port number of the TV. So in addition to port, you might want to say, which TV it is, right? Sometimes that might be useful to know, to identify which TV it is. So what we will do is we will take the name of the TV because we might have so many TVs in the house. We take the name of the TV. So here I will say Samsung and port is 10. So I can maintain the name here if I want. So it's string name, and then here In the constructor I will set name is equal to name. So we still need the TV constructor to initialize anything that is required for the TV class that's not in the base class. So here you can see I have created a TV called Samsung and the electrical port is 10. So now T dot, we can on the TV. I can say T dot increase volume and T dot off. So how do you step? So I'll increase the volume by 1. So here I will set the volume to 0 initially. So whenever a TV turns on, we are making sure volume is 0. Okay. So far is it clear? Or you have any questions? Wow. Good, everybody is getting everything. Even this part? This one, constructor. Okay, so what happens is the device has one constructor, right, which takes P as the input. Right, suppose I have a default constructor saying device which doesn't take any input and say port is equal to 0 here. Right, then I don't need this. But what will happen is, because whenever I create TV, I also need to create also need to initialize device, because whatever the properties of port is, that also needs to be initialized. But I need to call for that. Device has its own constructor, and we know that constructor has to be called when the object gets created, right? So when the constructor of the derived class is getting created, we also need to call the constructor of the base class, because by the end of the constructor the object will be created and people will start using the object. So we need to call the constructor of the base class, because in the you might say that why can't I initialize the base class inside this constructor? That may be one of the questions. But the thing is, even in this constructor I might want to use the base class value sometimes. Here I might want to straight away start using port or send signals to port or something like that, right? So for that the device has to be first initialized. So C++ gives you a way to do that. You use a colon and then call device. So what this will do, this will call the constructor of the base class before it goes into the construction of the derived class. So if I don't give anything, the default constructor will be called anyway, but since I didn't have a default constructor, it was complaining, so I gave the overload constructor. But since we are taking the port as input, we want to initialize the device with that port number. Is that clear? So let's see how the program flow goes, so that you will understand how the construction happens, how the whole flow goes. So let's first build it. Okay, good, succeeded. So first we are creating the object. So first thing it goes is okay, so first thing it goes is, oh, because I defined string, that's why it went there. Okay, anyway, so first thing it goes inside is the TV constructor, because whenever we create an object, the first thing that gets called is the constructor. And before it goes into the construction function, it needs to call the constructor of the device. So the name here is Samsung, port is 10. So we can see immediately the device constructor is called, with port value 10, and then the value will be set. And then once that is done, the constructor of the TV is called. So by this time the port is already set. If you see the TV dot, if I say this colon P, so this, let me see, immediate window, if I say this P, oh, port is called port, it will say 10 now. So the TV object is already initialized with the port number 10 because we call the constructor of the device, and the TV has all the members and functions of the device. So with that it is initialized. So the constructor is called name is set to Samsung, and then we return. Okay. So now what happens when I say T dot on? Because there is only one definition for on, which is defined in the device class. So here when you say T dot on, whatever is implemented in the T dot in the device, it'll run. Say in this case the port is, okay, it's not entered. Okay, so here the port is 10. So it will send signal to port so that the TV becomes on, and then we go into the increase volume, which is in the TV class, and then the volume is increased, and then when we say off, it will come to the off of the device class, whose port is 10, and then it will send the off signal to the port. So this way the function gets executed. So suppose I have another class called computer. Which also does have inheritance from the device. So I'll say for the computer I don't have volume, say, and here also I take name and port, and then I don't have volume, so I set the name, and instead of increase volume I will have something called void open disk, and I'll have void close disk. So instead of volume, I have created two different functions for computer, which will open disk and close disk. So maybe for that I need to know, in the computer I might need to know the address of the disk. Maybe I'll say port, I'll say another int disk port. So here this disk port is equal to disk port. Okay, so here I can send open signal to disk port, something like this in the computer. It may not be a electrical port, it could be just like USB port, it could be some other port. So this is sent close to this port. So when I create a computer here, now I need to define three variables. One is name of the computer, say it's Dell, and port of the electrical port, which could be 11, and disk port could be like 1034, something like that. Okay, so now when I say C dot on, first I'll on the computer, and then I say C dot open disk, C dot close disk, C dot off. So now when TV gets created, its port T dot port value will be 10. When computer gets created, C dot port value will be 11. So those two are two different objects. So T, size of T will be the total size of whatever volume, name and port. Okay, and the size of computer will be total size of name, disk port and port. Did you get that? Because the size of the class of a derived class will be the size of the base class, the members of the base class plus its own members. So is this clear how to derive from class and its uses, and what is how the constructor gets called and how the base class constructor is called, and how you can use base class functions? This logic, this could be any logic. I've just told I'm increasing the volume by whatever step you have input. Yes. Oh, I've given increase volume 1. So I've named it as step because it says, like, what is by how much steps you need to increase the volume.
So we cannot declare that value there. We have to declare in the main function.
No, I mean, you might want to increase by 2 steps, right? Right? You don't want to hard code it to just 1 or 2 or whatever. And here I'm just giving the programmer whatever volume he wants to increase, right? So suppose in the if you have an app in the home automation and you want to increase the volume, if you just give plus sign, if you just say increase volume, and then every time you do it, it's hard coded. But you can give the user his option. I want to increase the volume by 10 units or 5 units or whatever. So I'm not hard coding it. I'm leaving it to the user, or in this case programmer. Understood? Okay, so let's get back to some of the theoretical aspects of it. So you remember I defined protected. So I made these protected. So we know, like, why we need protected, because protected means the same class obviously will have access to both public protected and its private members. The derived class will have access to public and protected members, but it still cannot access private members, even though the class still has private members. I mean, because the size of the class is nothing but its own members plus the base class members, it still cannot access the private members, because the base class implementer has told you don't know how to use this, so don't even bother about accessing this. And obviously we know for the other classes, public is accessible, private is not accessible, and protected is also not accessible by other classes. Protected is only for derived class use. So is the access type concept clear? Okay. So what all is inherited? When I inherit from base class, I inherit everything, but what is not inherited is the constructor is not inherited. So in this case you saw that I had to write my own constructor. Without the constructor, it will just call the default constructor. It won't call the, I cannot, without this I cannot just say initialize with port P. I need my own constructor here. And the operator overloading members won't be derived, and the friends will not be derived. So except these three, everything else will be derived from the base class. So the types of inheritance. You saw that I mentioned when I derive, I said public. So when I say public, what happens is it's like whatever is public will remain public, whatever is protected will remain protected, whatever is private will remain private in this class. So in this case, port will remain as protected itself. So suppose because I do another inheritance from a TV, so I say class Samsung. This is called multiple inheritance, by the way. So I say public inherit from TV. Okay. So now to inherit from TV, I need to know which are its private, public, and protected members. So in this case, TV had done a public inheritance from device. So whatever was protected will remain protected in TV also. So so I'll be able to access the Samsung. Whatever is public obviously is accessible, and whatever is private is still not accessible in the Samsung. But suppose I want to say I don't want it to access. Suppose if I make it protected. In protected, what happens is all the public will become protected in TV. So you won't be able to access if there is something called on and off. You won't be able to access in the main program. You can see that this is inaccessible because when I said protected, it made all the public members protected, and protected will remain protected, private will remain private. Suppose I make it private. When I make it private, it means that everything will become private. Only these ones will remain public because these are all newly defined. Everything else will become private. So if I derive from Samsung, I cannot even access port because port was protected here, and TV made it private. So everything became private. In the Samsung, I won't be able to access the private members like port and etc. because this is a way to hide some of the things from when you do a multi-level inheritance. You can again hide some of the base class members as and how you want. So that's why we have three different types of inheritance: public, protected, and private. Is it clear? So what are the types of inheritance? So one we already know. It's a single inheritance, like person derives from a student. So this is called a single inheritance, like I am inheriting from a single class. So I can inherit from multiple classes, multiple base classes. So a person can inherit the functions of a son, father, or husband. So in that case, he will have accessibility to members of son, father, and husband, all the three. So it will be something like this. Suppose I have another class called electronics something. So we know that TV is not only a device but also an electronic device. So I can derive from electronics. So now if electronics has some methods like I don't know what I can think of, say what would be memory size, right? To get memory, something like this. So now on TV I can even call t dot get memory. So in this case it will call the get memory of the electronics class. So now TV is not only a device but also an electronics device. So whatever the properties of electronics it will get, whatever the properties of device also it will get. So is that clear why the multiple inheritance is required? Okay. So and multi-level inheritance, we just talked about it, like device TV derives from device and Samsung derives from TV. So this is called multiple inheritance. So is multiple inheritance also clear? So multiple and multi-level. Multiple is deriving from multiple base classes. Multi-level is there is multiple levels of inheritance. Sorry, Chitra, you had some question? Okay. Okay. Good. Oh, is it because I reduced the resolution? So maybe that is working. Oh, I'm glad finally. Hope I would have done this earlier. So, sorry about that. Yeah. So there is another thing called hybrid inheritance. And also I want to talk about the diamond inheritance problem. Like we will get some problems when we do this kind of inheritance. Suppose we have a base class called storage, which has two functions, read and write. And there are two classes deriving from C storage, transmitter and receiver. So these two are the child classes of storage class. And then say radio will have both transmitter and receiver. So it will do multiple inheritance from both transmitter and receiver. So the problem here would be, let me show you. Okay. So suppose I have a class called C storage. This has two methods, read and write. Okay. So I have receiver RX which derives from C storage. And I have class TX which also inherits from C storage. I have another class called radio that inherits from both transmitter because it needs transmitter functionality and also receiver because it needs receiver functionality. Okay, and it can have its own things. But our current focus is not that one. Our current focus is to focus on the diamond inheritance problem. So in this case, I create an object called radio. Okay. So I created an object called radio, and I say write 3 or transmit because I wanted to transmit 3. So I write 3. So can you see what is the problem here? It is saying write is ambiguous. So the compiler is getting confused because RX also has method read and write. TX also has method read and write. Now when you say R dot write, now the compiler does not know which write I have to call, whether from the receiver side or the transmitter side. So are you able to get the problem?
The variables public variables both has right RX and DXS.
Yes. So when you say radio.write, the compiler is not sure which one to call. So compiler is a little stupid here, so it doesn't know that the read and write was derived from the base single common base class. So how do we solve this problem? So C++ gives a way to solve this problem. I can do a virtual inheritance. I can specify virtual here. So now compiler will know that when you say read or write, it has to call the read or write of the base class. So now the compiler became intelligent. Did you get that? Okay. So these are mainly the core concepts of inheritance. So please go through the I'll come up with the exercise by today so that you can kind of practice some of the inheritance on your own. So probably once I finish with the presentation, I will kind of post the exercises. So please practice that. And I wanted to touch on one topic which I had missed, which is called I don't know what they call it. Hold on one second. So there is a concept called optional argument in C++. Suppose there is a function called create circle which takes radius. Oh, I don't take say function. Okay. So say this will return circle class. So if I have a class circle, it will return circle. So obviously when I call the function called create circle, is equal to create circle of radius 3. Okay. So how do I make this optional? The input as optional. So when I make input as optional, that means I want to be able to call it like this, right? C2 circle. But when I call this, I don't know what the radius is. Suppose you give an option saying that if you don't specify anything, I will say radius is 1, something like that. So there is a way you can specify the default value of the parameter. In this case, what happens? The first case, the radius will be 3, r will be 3. And inside say I will create a int radius r public circle int r So I have this. So here I'm just saying return circle 3, circle R. So what this function is doing is taking the radius R and it is creating a circle and returning it. So in the first case, let me build it, make sure it builds fine. Okay. So in the first case, what happens? I've passed the value 3, so it comes here. Even though the default value is 1, but if I pass the value 3, it'll get overridden by the value that I passed. So in this case, a circle with radius 3 is created. And in this case, I have not passed anything, so it will come here and the value will be set to 1. And here in this case, the circle with radius 1 gets created. So this is how you can use default arguments. The same thing is applicable even within the class, whatever function you create. For example, if I know the port of a TV, just in case, I can specify the value here if I want 10. So in that case, even if I don't pass anything here, if I just create TV with I can just create a TV with just the name, the port is automatically assumed to be 10 in this case. So there is no error. So the only condition is if you have multiple arguments, the argument with the name has to come in the end. It cannot come in the beginning. Suppose if I do like this, and if I have int something else, diameter or something like that, right? This will get confused. The compiler does not know whether the value you pass 3 is for R or it is for D, right? So if you build it, is saying default argument not at the end of parameter list. So because it gets confused here like this, you have to always define the default argument, the argument with the default parameter in the end. So that's when it knows, okay, 3 is the diameter and radius will be automatically taken as 1. And this is not valid because you have to specify at least D here. So if you can make that one also as optional, then you can define this way. But here also there is a problem, I think. No, there is no problem. Okay, in this case 3 is for D and R will be 1. Let's confirm that. So in this case, D will be set to 3, R will be set to 1, because you passed only one input. Whatever the first one, it will take as that value, and the other one the default values as well. So that way you can define default values within the function for any function. It could be a member function, constructor, whatever. So the same concept is applicable. So is the optional argument concept clear?
We say int R is equal to 1 and then after that int D is equal to 0.
Yes.
Why it's not taking R value as 3 from here? But when it says that D is equal to 0, taking directly. Why? It can also take R is equal to 3, right?
Yeah, but you don't want to confuse, right? I mean, there has to be one rule. I mean, when you say 3, how will the compiler know whether it's for D or R? So what it has made one rule. that it will start from here. If you give 3, it will take for the first argument. If you give yeah, it will go to R. Yes, whatever is the first thing, it will go to that one. And the optional argument should always be specified in the end. Like I cannot specify d is equal to 0 and int r. This is wrong. If I specify like this, it is wrong. Either both of them will become default argument, or it has to come in the end. I can specify w. This is perfectly valid. Whatever value you give, it will go here, or you can give 2 values, or you can give 3 values. But the non-default cannot go in the end. Then compiler will get confused to which value you are giving. Okay. Okay, so that is default argument. So I want to stop here. So I'll come in the next class. We still have 3 concepts actually. Two concepts we need to cover, but one operator overloading. I think one of our members at least is having a problem. So is anybody else also wants me to go to operator overloading? Okay. Okay, just okay. I'll cover it in the next class. I just wanted to show operator overloading just as a concept. Yeah, you might be implementing that, but it's good to know that these things are there. But yeah, I'll definitely spend some time in the next class to go through the operator overloading. We have polymorphism, which is a variation in the derived inheritance. So we have to cover that. And there is something called templates in C++, which is also very useful. So we have to cover those two. And then basically I will be done with the OOPS introduction, or if you want, I can even cover design patterns too. Maybe I can take one class. After that, we will be done with C++ with object-oriented programming. Then, based on the directions, I'll see whether we need to go and learn C# or something else. That we will see. Okay.
And one more query about the Visual Microsoft Visual Studio. It's not possible to install it in Windows 7. So that live doesn't work.
Why? What is the problem? What was?
There is no icon coming to start up. Installation shortcut or icon.
No, if you just click on start, and then if you should be there in programs, right? If you go like this, in the programs you won't be able to see Visual Studio.
No, I'm not able to see.
Are you sure installation is complete?
Yeah, it's complete.
Or you can do one thing. If you can command prompt and just type dev env. It won't show. I don't know why. Maybe if you go to C program files, Microsoft Visual Studio Common. Oh wait. Okay, not here. I think you have to go to program files x687 Visual Studio x86 Visual Studio, and I don't know where is the. If it is, let me know if it's installed here or not. Yeah,
I could able to see here. I saw that it's installed in program file. Same way the common 7 PC are there.
so this is the path. This is the path. You should be able to see the dev env. Let me put it in here. So it should be in something in like this, dev env. If you open this, this will open the UI. Okay. Okay, good luck and good night.
Happy Deepavali to you.
Oh, thank you. Yeah, happy Deepavali to everyone. Okay, good night.